Hello everyone. This video is regarding the top k frequent element solution. I have already added a detailed explanation for the problem statement. You in my previous video. You can refer that video. I'll be adding the link of that video in the description. Uh, Cool. Let's start with the problem solution for this problem. Right. So, what does this problem? How can we solve this problem, right? So obviously we have to find the top k most frequent elements in this. So there's nothing written over here that the elements are in sorted order, right? Since we can see in this example it is sorted, but it is not ensure that it is in sorted order, right? So what we can do is we can use a brute force approach. You can say this can be a brute force approach, which can be done using the hash map and sorting, right? Cool. So let me explain the solution first, then we'll come to the coding part of this, right? So let's assume this is the problem. Let's say 3 2 2 1 1 1, right? So let's say we'll create a hash map for this, right? Where the key represents the this represents key represents the number, and the value represents the frequency, right? So for 2 the frequency is 2, and for 1 the frequency is 3, right? So in this we can see it is in ascending order, right? But the most frequent element it is in the last, right? We can sort this and we can get this frequency like 3 2 1, and since they have asked for top k elements, which is 2 here, we'll return these two indices, right? uh, so sorting takes O of n log time, so this can be solved using O of n log times, right? So as I suggested, um, we'll be making a frequency map where we'll generate a frequency map. So this map will be generated with the help of this part. A frequency map is generated, so the counter and the numbers, this comes from our collection framework. So from collections import counter, right? And yeah, for now we need counter as cool. So now so we can say this is count frequencies of elements. That's right. Sorry. So the next part is sort the elements by frequency in descending order, because we need the highest frequency on the top, right? So we can say sorted frequency map will look like sorted frequency map dot items. Will be sorting on the items where key is equal to mbd lambda x comma 1, and the reverse is true, right? What will be the third part? The third part is we have to return only the top k element. Return the top k elements. So we'll be taking out the top k elements from this and returning to the answer. So what we have to return? We have to return the numbers, right? So the numbers are the values here, right? Okay. So item of 0. Okay, sorry. So wait. Let me for well, let's say you can say each in where sorted frequency map. Okay, we'll get this and we'll return each of 0 because we'll get the key and the value, right? And we have to return the 0th value, which is the number here, right? Let's try to run this and see if it works. Okay, if it works, like if you submit also, it should work, but let's try it out, right? Cool, this works. So I've already okay, I explained the time complexity. Usually the sorting takes O of n log n, and the space complexity we have used a frequency map, so the space complexity will be n, right? So I've already added a comment. I'll add these comments here, right? I've already written this, so I'm just doing copy paste, right? So this is a sorting wala solution, right? Okay. Okay, so we have one another better approach for this, where we use the heap, or you can say the periodic queue, to solve this problem. Okay. Mostly we'll be using min heap for solving this problem. Okay. So what we'll do is we'll have the frequency count with us, right? And we need the highest frequency on the top, right? So we'll be using the min heap for this, right? So what we'll be doing is we'll be pushing the elements inside the heap, where we'll be keeping the heap size to k, right? And at last heap will consist of only two element, and we'll be simply returning this heap. Okay, so let me show you this solution. I hope it's clear. Let me walk through the code, right? Count the frequency of the elements, right? So first thing, same thing, we have to do the count the frequency of the elements, because without the frequency count we can't do anything as such, right? So we'll be counting the frequency of the elements, because this is a frequency map that we have to create, right? Now using a min heap, we'll be keeping the track of top k elements, right? So I'll add a comment using the min heap. You can say use a min heap to keep track of top k elements, right? Okay, we'll declare the min heap here. Min heap, right, for number comma frequency, right? In frequency map dot items. Okay, so what we'll do is we have to use this thing. We have to use a collection, one more import for this, which is heap import, right? Heap queue, right? This is a package in the Python library, heap queue, which gives us the access to heap functions and all, right? So we'll be using heap queue to push elements to this, right? So push elements to this min heap, right? Heap queue dot heap push, right? Where are we going to push? We are going to push in min heap. What are we going to push? We are going to push the frequency and the number. Okay, because we need both the things as such, right? Frequency is used to we are pushing frequency because we have to keep track of the highest frequency, and we are pushing the numbers because we have to return the answers, right? So if now we have to see if the min heap size does not exist the number of solutions that we need, right, which is k here. So if the length of min heap is greater than k, right, uh, usually size of heap should be k, right. So what we'll be doing, we'll be popping the elements heap q dot heap pop, right. What will be popping, the min heap will be popping this min heap, right. So this will pop the elements which has less frequency, right. Matlab, which has let's say there are 3 elements now, right. So we'll be popping out the element which has the less frequency. In case of 1 2 3, we'll be popping out the 3, right. Now the last part is what? Last part is to extract the answer, right. So we'll be returning for frequency comma number in min heap, right. We have 2 elements here, right, frequency and number. We'll be returning the number itself, right. So this is using normal approach. So let's try to run this. Okay, this also works. So I'll just add few comments here. Extract the elements from the min heap, use a min heap count frequency, right. So I've also added a print statement for a problem. So I'll show you just how does this frequency map looks at this state. It looks like this, right. And yeah, and we can always print this min heap here to see the min heap, right. So I'll just run and show you guys if it allows me to show me the print statements here. Okay, so we can see here okay, this is commented. On the initial state we have pushed 3 comma 1, then we have pushed 2 comma 2, right, and then we have pushed this 3 elements, right. Let me print this again at this state, right. So it will tell us how it is actually, what it has popped out, right. So okay, so this is the first statement for this print statement, and this is the another one. So if the length is k, right, so let me add a comment here after pop, right, to be more clear. And oh, I think this will not work. Let me add this. Okay, so we saw that it is only going to get popped once, right. So previously we have pushed 3 comma 1, then we have pushed 2 comma 2, right. The highest frequency is on the top, and then we have pushed 1 comma 3, right. And what it has popped is so it has popped this, right. Let me try to submit this and see. I think I might have to comment it out. Okay, it says time limit exceeded. Okay, let's see what is wrong here, right. So we have the frequency counter here, we have the min heap here, we have the number, frequency, we are iterating over the items, we are using heap min to push the elements, frequency comma this. If the length is greater than the size, we are going to pop it, right, and we are going to get the number from the frequency and the min heap, right, length of the min heap. So in this you can see Let me see what is wrong in this. Ideally, it should have popped this element, but what it has done is it has popped this element, right, which is wrong. So it is not sorting the elements based on the frequency, right? So let's say if I comment this things out, maybe okay, this is correct. Let me try to submit this. Okay, this is accepted. I don't know what was wrong here. Maybe because of this print statement it is giving us faulty data. Okay, let's test this again. So after pop we can see we have 2 comma 2 and 3 comma 1. Okay, sorry, so I was wrong. We have the frequency first and the element at last, right? So this looks fine. So I'll again show you guys. I got confused by 2 by 2. So we have 1 with a frequency of 3 because 1 was the first element, right? Then we have 2 with a frequency of 2, right? So, at this state we have 2 elements. So both those 2 elements are in the heap, or you can say the min heap, right? After that we have pushed 1 1 comma 3, right? Where 3 is the element number 3 and has a frequency of 1, right? And since this is a min heap, it will pop out 1 comma 3 which has the least frequency, and you can see after pop we have this thing, right? And we are getting time limit exceeded here because of the print statements, right? And I already showed you once that. Let me submit it again for you guys. Okay, yeah, so the problem is accepted, right? So I've already written some comments for you. Maybe you guys, if you want, you guys can go through it later on. For this again, what I want to say is the time complexity for this problem is mostly counting the frequency, which takes O of n time. Pushing and maintaining the heap size takes O log k of each element. So the total heap operations is n log k, right? Because they are n elements, right? And the space complexity will be O of n plus O of k, because we are maintaining an O of n hash map size and O of k for the heap, right? So I've already added all these things here, so you can see the overtime complexity of O of n log k and the space complexity of n plus k, right, which is the frequency of this. And I've already added the same example here for better project. So this is using min heap, or you can say priority queue, right? So mostly this solution should get you through the interview, but in after doing a couple of research, I found one better solution, or one more solution for this, which is using a algorithm called bucket sort, right? So let me explain that to you as well, right? So the other problem statement is the bucket sort, right? I'll remove this. Okay, so in same this problem statement, we need the frequency, right? So the first thing will be the counting of the frequency, and afterwards we will be doing the sorting, right? So optimal bucket sort is optimal for bounded frequency, right? Since the frequency are bounded, this is optimal solution for this, right? So what we'll be doing is we'll be creating a bucket where index represents frequency. Okay, so index will represent the frequency, length of number plus 1, because the okay, so we'll be creating a bucket where index represents the frequency. So we'll be creating a bucket range length of the numbers, right? And plus 1 will add, because maximum possible frequency of any number is length plus 1, right? Okay, I hope this is clear, right? Okay, so we have created a bucket. We have created a bucket for length plus 1. So what you can also print this bucket to view the bucket. How does it look? And what we have to do is add elements to respective frequency bucket, right? So we'll be adding elements to respective frequency bucket, right? So for number and comma frequency, we already have the number in the frequency, right? Where in the frequency map, right? Frequency map items bucket में we will be adding the numbers for the respective frequency. Append number, right? Now we have to, let's say we have the answer in the result array. We have to return the out the array, right? So for now what we'll do is we'll pick up the numbers of the from the array and return the answer from the bucket for in range. What is the range? Length of the bucket, right? Bucket -1, right? And we are doing -1 to reverse the bucket order, right? In descending order we are going to operate on this. For a number in bucket at I, bucket at I will consist of a number. Will append this to the answer array, right? If the length of the result is equal to k, right? We have found those two numbers, right? We'll be simply returning the result. Since there is always a solution for this, so we'll be returning the results for this, right? So let me try this. I've already added a comment here. Okay, what it is saying is bucket frequency dot append. Tuple object has no attribute append. Okay, why is that? Bucket frequency dot, I think the spelling ABBEND. I already had a comment here. Let me show you that comment. Okay, let me okay, so this was supposed to be a this thing. Okay, array, right? Okay, sorry. Okay, so I added comments here. So for better understanding, you can see we have counted the frequency and then we have created a bucket here, right? If you want to see the bucket, you can see and print this bucket, right? So 3, 4, 5, 6, 7, right? So I think this is for this problem. 1, 2, 3, 4, 5, 6, 7. We have created one extra bucket, right? Because the frequency can be 6 and 7. Because the frequency can be 6, right? This represents 0, 1, 2, 3, 4, 5, 6, right? Added the numbers. We are going to add those numbers in the bucket, right? So what we are trying to do here is we are adding that number in the bucket. Because a single number can have, because multiple numbers can have a same frequency, that's why we are accepting an array of this, right? So you can see this is an array of arrays that we have created, right? If two numbers have same frequency, that will be present inside the same bucket, right? So what we have done is buckets having a particular frequency, we are adding that number, right? If there are multiple numbers in this we'll be adding those numbers, right? And then what we are trying to do is we are getting the we are going to iterate over this, and we are going to get the elements which has the highest frequency. So we are iterating on this bucket, and from length of the bucket -1, and in the descending reverse order, right? Because we need the highest frequency, right? Okay, let me try to submit this and see. Okay. Okay, I hope this is clear. I forgot to mention the time complexity and space complexity, TC and SC, right? So you can see the space complexity. I'll tell you, we have one hash map, we have one bucket, and what else, and we have a result, but the result we have to return, so we are dependent upon two things. We have one bucket and we have one hash map. So I think the time complexity, uh, so let's assume the time complexity for the result map also, right? So the time complexity will be O of n plus O of n plus O of k, right? Overall, it will be O of n only, right? And the space complexity will be for this O of n, right? For this O of n, then then again we are iterating over this, which is what counting frequencies of n. Then we create a bucket of this size empty, which is also O of n, right? Creating a bucket of size empty because we are using a for loop here, and then we are adding each elements with respective frequency. Then again O of n here, sorry, O of n here, and at last we are going to iterate over the whole bucket, right? So again O of n here, right? So I hope this is clear. So maybe I'll write it here for better understanding. This takes O of n time, this takes O of n time, this takes O of n time, and this takes O of n time. So obviously this is overall O of n only. Okay, let me submit this again. Okay, yeah. So I hope this works. The most optimal way to solve this problem, you can already see, is like, O of n log n, where here is the time complexity if you are using brute force sorting, and if you are using a heap or priority queue, it also takes a space of O of n plus k, and the overall time complexity is O of n log k, right? And if you want to do it better, you can use a bucket sort uh, where we are aggregating the numbers based on the frequency, right? So we are creating bucket for frequency wise, right? And yeah, that's it. Thank you, and please like and subscribe.